Method of least squares. This method is an accurate and simple way of calculating the line of best fit. The line obtained by this method is called the least squares regression line. Let us understand how this method works. We assume a line of best fit. We calculate the distance between each of the data points and the line. We square these distances and add them up. We can see how the sum of the squares changes as we move the assumed best fit line. The least squares regression line is obtained when sum of these squared distances is minimized. This then becomes the best fit line. Let us try to derive the formula to get the equation for the best fit line, the least squares regression line. We denote this line by y hat is equal to a plus bx, where b is the slope and a is the y-intercept of this line. We can see that while calculating the distances between the individual points and the best fit line, only the difference between the y-coordinates need to be considered, as the x-coordinate does not change. For point 1, the square of a distance will be the difference between y1 and the y-coordinate of the best fit line at x1. The sum of the squares of these distances for all the points is minimized when the best fit line is obtained. The formula for the slope and y-intercept of the least squares regression line is given as b is equal to summation x minus x bar times y minus y bar over summation x minus x bar the whole squared. A is equal to summation y minus b times summation x all over n is equal to y bar minus b times x bar, where n equals number of data points. X bar, y bar is a point on the best fit line where x bar is the mean of all the x values and y bar is the mean of all the y values of the data points. Let us again calculate the equation of the line of best fit using this method. For the example that we considered earlier, that is, the marks scored and the number of hours per week spent watching television, we need to calculate the values of x minus x bar, y minus y bar, x minus x bar, y minus y bar, and x minus x bar, the whole squared. First we calculate summation x is equal to 254 and summation y is equal to 878, giving us x bar is equal to 254 over 10 is equal to 25,4, and y bar is equal to 878 over 10 is equal to 87,8. Now, for x is equal to 5 and y is equal to 142, x minus x bar is equal to negative 20,4, y minus y bar is equal to 54,2, x minus x bar, y minus y bar is equal to negative 1,105,68, and x minus x bar the whole square is equal to 416,16. For x is equal to 9 and y is equal to 129, x minus x bar is equal to negative 16,4. Y minus y bar is equal to 41,2. X minus x bar, y minus y bar is equal to negative 675,68. And x minus x bar the whole square is equal to 268,96. Similarly, we calculate the other set of values. We can see that the summation x minus x bar, y minus y bar is equal to negative 4,581,2, and summation x minus x bar the whole square is equal to 1,808,4. Now we substitute these values in the relevant formulas. We get b is equal to summation x minus x bar times y minus y bar over summation x minus x bar the whole squared is equal to negative 4,581,2 all over 1,808,4 is equal to negative 2,53. A is equal to summation y minus b times summation x all over n is equal to y bar minus b x bar is equal to 87,8 minus negative 2,53 times 25,4 is equal to 152,06. Hence the equation of the least squares regression line is written as y hat is equal to 152,06 minus 2,53x. We can draw this line as shown by joining the y-intercept and the point x bar, y bar that lies on the line. This is a very useful equation to have. It can be used to predict the marks scored by students if we know the average amount of time that they spend watching television in a week. For example, we can calculate the marks scored by a learner who watched 52 hours of television per week on an average as follows. Least squares regression line equation is y hat is equal to 152,06 minus 2,53x. For x is equal to 52, y is equal to 152,06 minus 2,53 times 52 is equal to 20,44. The learner would have scored about 20 marks in the exam. This equation can also be used to roughly estimate the number of hours of television watched in a week if we know the marks scored by the learner. For example, we can estimate the number of hours of television watched in a week by a learner who scored 100 marks in the exam as follows. Least squares regression line equation is y hat is equal to 152,06 minus 2,53x. 100 is equal to 152,06 minus 2,53x. X is equal to 152,06 minus 100 all over 2,53 is equal to 20,58. Hence we can estimate the learner who scored 100 marks would have watched about 20,5 hours of television every week on an average.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.